structures are one approach to define users customized data type. Normally we have fundamental data types, which comes as a bundle with the C compiler, and it includes various data types: integer, character, float, and boolean. However, in most of the problems, it cannot adequately resolve the problem, or it cannot satisfy our requirement in its original form. That is why programmer defines some data types, and those programmer defined data types are called user defined data types. Basically, we group certain fundamental data types like integer, say x, then float y. Let us suppose that this is two variables, and one more variable we have character z, say, and we group it under a common name. We group it and we give a name, give some name. For example, this is the name given, but however we cannot give only the name. To make the compiler clear about this grouping, we use this keyword struct. So it means that the struct collection is a data type which includes three different fundamental data types as a single group, and this becomes now an user defined data type. When in a program, first of all, if we want to write a program with some structured data type, suppose here I have the include std io.h, then I can have integer main. This is the function, main function, and this, let us suppose that this function starts from here. Within the main function, the structure is defined. In this part, we are defining the structure. Like other fundamental data types, we must have to define a variable or declare a variable. Suppose that C1 is a variable I want to declare. This C1 is a variable to hold data of UDT, of type UDT. Which UDT I wanted to store in C1? That is nothing but this struct collect. That means this C1 should be declared as struct collection C1. So this entire statement, will define C1 as a data type of this structure type. This is similar to the definition. Suppose that I want to declare a variable p, and I want to declare p to hold integer data. Then definitely I will declare this variable as integer. So also in this case, we are defining this C1 to hold the data of the type struct collection, who comprises of three different components, and that is defined and declared as using this statement. Suppose that I end here, I end this main here, end of the main, if I execute this code, let us go to this main memory. Executing this code, this is our main memory. This is the first statement to be executed. So it will reserve some space for C1. Similarly, this variable P also, it will reserve some space. This is identified as P. Compiler will assign certain address to it. Let us suppose that 4000 is assigned to C1 and 7000 is assigned to P. Now the size of P will be equal to size of integer. If I assume that integer occupies 4 bytes, then it would be of 4 bytes. Similarly, C1 also should be allocated certain space continuously, because this is a single variable of the type struct collection. To reserve some space, it will refer to its declaration. It has 3 different components. Suppose 1, 2 and 3. These are 3 components. And these 3 components, the first component is integer assuming 4 bytes. Second component is character assuming 1 byte, and third one is float assuming 6 bytes. So 6 plus 1 plus 4, that is equals to total 11 bytes will be reserved for C1. And the identifier given to the first byte will be C1.x, to second one it will be C1.y, and third one it will be C1.g. If I wanted to access this particular portion, I can give 2 names. One is C1.y and second one is the address of C1.y. So address of C1.y, if I go from this definition, it will be 4004, 4004. So this is the basic idea how structure is declared or defined in the program and how space is allocated to that variable. A structure should have a name, for example sample or collection, whatever we have given here. Then we have various components, and within the definition we include fundamental data types. Also it can include user defined data type as well. And we have one more structure, S2, and in this one I have one variable character C, and we have another variable, say boolean B. These are two structures. Here I can define one more structure before the int starts, like this. Say struct s11. This is the name of the structure, and what I want to do, I want to include one variable of integer P, and then I have one more variable which is of the type structure S2. Let me tell this S2 too, like this. That means in this program we have 3 user defined data types. One is S1, another one is S2, and third one is S11. However, S1 has some special feature. It includes both S1 and S2 as its member. We can include another one user defined, this is user defined data, as a member of another user defined data, right? And this concept is called nested structures. Struct sample, for example, sample, and this declaration is given as global declaration, and within this I am declaring one variable, one, which is of the type struct sample. And if I go here, this is S1, this is S1. Some address will be given to this, and it will be divided into two parts. First part is named as X, which is of the type integer, and second part is named as Y, which is of the type float. Now I want to access this one. I want to scan some data from user, and I want to put it here. What I can do, first of all, I can consider S1X and S1Y can be considered as the single variable or single independent variable. There is, and I have to write down the statement scanf with the format specifier %d. Format specifier %d. In any scanf statement, the next parameter of the function is to give the address operator, this address operator. After the address operator, immediately I should give the name of that variable. I know that this name of the variable is S1X. X is small, exactly whatever I am giving here, like this. Similarly, I can also use the statement scanf for the second component of the structure as %d, then certainly not d. What is this? What should I write? %f. I should write here %f because I understand that individual components, if I consider, that is of the type floating point or float. That's why I'll do the same, ampersand of s1.y. Suppose that for x user typed 7 and for y user typed 2.5, then these values will be stored in those locations. I have entered 7 here and I have entered 2.5 here. Let us come to the concept of pointer. When in a program I define a variable, now what I will do, I will use a pointer. That means by this star I mean that p is not a variable to store any integer, float or some other data type. Rather, p is defined as p is a variable who holds the address of another variable. The location the location whose address is stored in p, only integer, right? So what does this mean? First of all, p will be equal to some value, any value, say 12. If I see a definition, means that this 12 is nothing but some memory location whose identity or which address will be 12. And now I can store data in this location, in location number 12. Say. Whatever I will store, that should be of the type integer. If I say star p is of the type integer, that means this location can hold integer. However, the value which is stored in p, p, this one is always address, and address is always integer. In short, what we can say, any pointer which is defined as some fundamental data types or any other data types, this data type indicates the data type of the target variable. Target variable means that since p is a pointer, so we say that p points to the memory location 12, and the data stored in memory location 12 is called the target data. So if I say p points to location number 12 and this 60 stored in location number 12, then 60 becomes the target of the pointer p, and the data type of a pointer indicates the data type of the target variable. When the compiler will see this statement integer star p, what it will do, it will reserve some space, and initially it is said at the time of declaration this pointer p is pointing to nowhere. That means p is pointing to nowhere. So if I write a statement p is equals to ampersand of n, then address of n will be stored in this location now, 1000. So 1000 will be stored here. 1000 will be stored here. And it seems to be p points to this location. Actually, in the compiler, there is nothing like a pointer, this arrow mark. But what it means that p is holding the address of n, which is equals to 1000. So that is why if I want to access the content of this location, suppose that n equals to initialize as 70, for example, if I wanted to access the content stored in n, then I can use p, or I can use n. If I use p, I have to use this star symbol. If I use n, then I can use only n. So this declaration struct sample s1. Now here s1, this one is a variable. This is s1, this is s1. What I want to do, I want to declare one variable p, which is a pointer type. It's a pointer. So I have given the star, but this pointer is not pointing to any integer or any float number. Rather, I want to point p to a variable or to a data type struct sample, right? So certainly the compiler will reserve some space here. It is aware that p will store the address. If I want to initialize p, because you know that at this point p is pointing to nowhere, means p is pointing to nowhere. If I do p equal to ampersand of s1, then as a result of this statement, p will have the address. Suppose that this address is 7000. So 7000 will be stored here. That means 7000 is this one now. If it is this, then p seems to be pointing to this variable. So it implies that now p is a pointer. P is a pointer that points to s1. If this is the case, then since I am defining a pointer p that points to this s, so I must have the provision to access this s1x and s1y using p. I can write down this statement. Say I want to access the x1 component. What I will do, I will tell x this one, then the name of that variable. Similarly, I can also access as y like this. So this will be equivalent to s1 dot x, and this one will be equals to s1 y. We have seen a structure sample of or anything. I have one declaration like this, and I can have any fundamental data types or any form of the fundamental data types. I can take x here, and definitely I can also have a pointer p here. This is possible. The main memory, then in the main memory, s1 will look like this is, say, struct sample s1, and s1 will be like this. So first one will be x, it will be of 4 bytes. Then this is p, it will be of 6 bytes. Why it is 6 bytes? Because it is supposed to hold some address. And what address it will store? It will address some address. It will store some address. Let us suppose that this is one address in the main memory. Let us say this is 1000, and this is s1, and we have some location here. Maybe this location is 7000, and any address, any valid address can be stored here. We can store any valid address. However, there is a condition. The condition is the address stored here, maybe this one 7000. If I store 7000 here, that means this one is the address of this 7000. In this place, what I can store? I can store only integer, because this data type indicates the target data type of the target location. So if this is the case, then I must have to have one declaration of the type integer, say I1 for example. Then I must have to tell s1 dot p is equal to ampersand of I1, provided this is I1, and this I1, address of this I1 will be stored here. And since I1 is defined as integer here, so this is possible. So this p seems to be pointing to this one. This structure sample can have one more member of any other structure, valid structure that defined in the program. For example, say I have another declaration structure in the program, structure, say temp, for example, temp. Within this I have only one variable, member variable. This is not good to declare a structure for one variable, of course, but for simplicity I am doing that. And here this struct, I will write struct temp say t, temp t. Similarly, I can also define it as a pointer. That is also possible. This is s1. This is s1. It has 3 components. First component is x of the type integer. Second component is a pointer to integer. It takes 6 bytes. Similarly, third one is also a pointer with name is t. This is y. This is p. Sorry, this is p. This is t. This is also pointer. It will take 6 bytes. This p will point to one integer. Here I can store integer, and here this is same. Okay, this is equal size. Where it will point, I can store what I can store. I can store only struct temp. Now, can I write this statement? Suppose I have a structure struct, then first, let me tell first, this is the name of the structure, and within this I am writing one variable integer, say data, for example, and I want to use a pointer here as a second parameter, star, say p. This is a pointer. But however, what I want to do, I want to declare this pointer, I want to include this pointer that it points to a valid structure. And I know that struct first is also a valid structure. Let me write struct first. Struct first star p, and let me close this. Let me draw it. This is S. This is S1. It has two components. First component of the 4 bytes, which is called data, correct? And second one is called P. These are two members. One is data, another is P. And this address, let us suppose that 6000. And I want to initialize P. P means S1P. S1P is equals to ampersand of S2. This field needs a pointer. This field P needs a pointer to structure sample. So that's why I am declaring S2, which is a valid data type of struct sample. But if I see here, S1 is also of the type same. So can I put this 9000 in this location? If I write S1 dot P is equals to ampersand of S1. What is S1? S1 is nothing but 9000. Ampersand of X1 gives you, S1 gives you 9000. This is called a self-referenced structure. Self-reference, because it is referring, this is called reference. It is referring to itself. That's why it is called self-reference structure. And the concept of self-reference structure like this